iRobot, Teaching the Basics of AI in High Schools. So here we have the authors and their affiliation, Austria. So let's read the abstract. Profound knowledge about AI will become increasingly important for careers in science and engineering. Therefore, an innovative educational project teaching fundamental concepts of AI at high school level will be presented in this paper. We developed an AI course covering major topics: problem solving, search, planning, graphs, data structure, automata, agent systems, machine learning, which comprises both theoretical and hands-on components. A pilot project was conducted and empirically evaluated. Results of the evaluation show that the particular participating pupils have become familiar with those concepts and various topics discussed. Results and lessons learned from this project form the basis for further projects in secondary school which intend to integrate AI in future secondary science education. Introduction and motivation. Artificial intelligence has become part of our everyday life. For example, intelligent household appliances, smartphones, Google, Siri, AI in computer games. Many of us know about the existence of services and devices based on AI, but hardly anybody knows about the technology behind them. Therefore, it is of great importance to already familiarize young people in schools with the technical background and underlying concepts, including algorithms, data structures, and programming or coding. Like classic literacy, which includes writing, reading, and mathematics, literacy in AI or computer science will become a major issue in future. Furthermore, with AI literacy, pupils will receive a solid preparation for subsequent studies at university level and their future career. Currently, computer science education in school does not focus on teaching these fundamental topics in an adequate manner. In order to overcome this shortcoming, we developed a high school AI course called iRobot, dealing with major topics of AI, computer science, automatons, agent systems, data structures, search algorithms, graph, problem solving, planning, machine learning. The course was divided into 7 weekly teaching units of 2 hours, comprising both theoretical and hands-on components. We concluded and evaluated a pilot project in representative Austrian high schools, which integrates robotics in its regular curriculum. Example, participating in robotics competitions, offering robotics electives, etc. Teaching the fundamental concepts and techniques of AI at school level is quite rare. Many approaches focuses on undergraduate or graduate universities at university level. Common approaches at school level only deal with some selected aspects of AI, for example, history, the Turing test, chatbots, neural networks, or use limited tools or platforms to illustrate AI concepts. In the following sections, we will briefly describe the methodology, which is the structure, content, teaching methods, the evaluation and results conclusion of this pilot project. Methodology. The project has been divided into 7 weekly teaching units, comprising theoretical and hands-on components based on the principles of constructionism. 9 pupils from grades 9 to 11, all with prior knowledge in robotics, but none in AI, participated in these lessons as part of their robotics electives. According to the concept of constructionism, pupils were actively involved in the learning process, and they included paper and pencil or programming exercises. Contents were adapted and set in context with pupils' prior knowledge in robotics. The course was structured around the following major AI topics. Automata were addressed at the beginning of the course since they form a neutral basis for describing systems, behaviors, and illustrate the decision-making process. Intelligent agents, simple reflex, model-based reflex, goal-based, utility-based agents were introduced. Graphs and data structures, stack queue trees, as well as a definition of a problem in the field of AI were addressed to create the basis for subsequent units dealing with problem solving. Problem solving by search was one of the main emphasis of the course since it is a fundamental technique in computer science or AI with many areas of application. Classic planning was addressed by introducing pupils to propositional and predicate logic, state space planning, as well as forward and backward chaining. Machine learning constituted the conclusion of the course. The focus was put on presenting and discussing different approaches to learning agents. Example, logic-based learning, knowledge-based learning, reinforcement learning, decision trees, and neural networks. Evaluation. The project evaluation was done using reliable quantitative and qualitative empirical research methods. In terms of quantitative evaluation, we applied a paper and pencil post questionnaire, comprising a self-assessment of acquired skills as well as feedback on the structure and teaching methods of the weekly teaching units. In terms of qualitative evaluation, we conducted semi-structured interviews with all participating pupils using a set of predefined questions as guidelines. A content analysis was performed after transcribing all recorded interviews. Further qualitative data was collected by using techniques of participant observation during the weekly teaching units. All collected data were treated confidentially and anonymously. Summarizing the evaluation results. The project succeeded in teaching high school pupils the foundations of AI. Pupils got a well-founded understanding of those concepts and the growing importance of AI. They are now familiar with various topics addressed during the weekly teaching units and will benefit from the acquired content in future. Example, when participating in robotics competitions, starting engineer or science studies at university. Questionnaire, interview guiding questions and data are available upon request. In this paper, we presented an educational project teaching fundamental concepts of AI and computer science at high school levels. We conducted an empirically evaluated pilot project in a representative high school with 9 voluntarily participating pupils in the spring of 2015. Weekly courses, theory and hands-on, held by university researchers covered major AI topics. Contents were adapted and structured with respect to pupils' prior knowledge and educational background. Results indicated that pupils are confident about the various topics addressed during the teaching units. The first pilot project was successful. Nevertheless, there were some drawbacks and shortcomings to be dealt with in future. These were not enough teaching units, small sample of participants, particularly different expectations of pupils prior to the course, and partly too extensive homework. Further analysis of gathered data is still ongoing and will be published in a later date, along with a detailed description of the course contents and structure. Results and lessons learned from the pilot project form the basis to adapt and improve the present AI courses. We are planning to conduct the project in other high schools in the next few years, pursuing our long-term goal of integrating AI in regular science education in high schools and to foster AI literacy. Here are some references: Teacher Education and Robotics Enhanced Constructive Pedagogical Methods, a high school project on AI in robotics, an action report. I'd like you to read the entire article, please. Thank you. And please answer the the Moodle quiz. I will be taking those marks towards your course mark.